Hello viewers and students, you are welcome again to my channel. Today we are going to be looking at organic chemistry. In this video, we'll be looking at series of teachings on a special and interesting group of organic compounds called alkanols. I'll be starting the series of teaching in this video. Please, before we proceed, kindly subscribe to this channel, share and like the videos you are watching, and don't forget to turn on your notification button so that you can always have access to the new updates. Most especially, the series of teaching I'll be starting today in this video, you can have access to the rest of these teachings in the next coming videos as long as you turn on your notification button. So don't forget to share and like as well. I want to draw your attention firstly to some things before we start to look at the alkanols. You agree with me that you are familiar with alcohols, especially in most of the daily products that you are taking. There are some things you are taking on daily basis that contain alcohols in them, such as hand sanitizers. Hand sanitizers are alcohol-based. They contain sanitizer. They contain alcohols. Hand sanitizers contain alcohol. There are some drinks also that some people do take, like alcoholic drinks, such as beer, wine, whiskey, and the rest of them. All these are what people take on daily basis, and they contain alcohols. So when we are talking about alkanols, alkanols are alcohols, and they are things we interact with as long as we are taking all these daily products, be it sanitizers or alcoholic drinks. So we are talking about alkanols. Alkanols are a group of alcohols, and we can also refer to them as saturated alcohols. Saturated because they contain a chain of carbon atoms that are connected together by covalent bonds, single covalent bond precisely. They contain a chain of carbon atoms that are linked together by only single covalent bond. That is why they are called saturated. And why are they called alcohols? Because they contain hydroxy group, which is a functional group in them that distinguishes them as alcohols or alkanols. So alkanols are saturated alcohols. Now, before we look at the full meaning of alkanols, I would like us to have a basic knowledge of how the word alkanols are derived. The word alkanols is derived from alkane. Is derived from alkane by simply replacing the ending E in alkane with OL as follows. That is, an alkane. An alkane is a saturated hydrocarbon. We are familiar with that in our previous lessons we have been taught. When this E ending in the name is replaced with OL, it forms the word alkanol. That's how we derive alkanol from alkane. And that is why alkanols are sometimes referred to as the derivatives of alkane. Derivative in the sense that they are derived from the parent alkane by simply replacing the ending E in the alkane with OL to transform to give a new compound called alkanols. For example, let's take examples of some alkanes. I hope you still remember some examples of alkanes, such as methane. Methane is an alkane. When the E ending the name is replaced with OL, it transforms to give the corresponding alkanol, which is methanol. Also, ethane. Ethane is an alkane. When the E ending is replaced with OL, it gives the corresponding alkanol known as ethanol. Propane is another member of the alkane series. When the E is replaced with OL, it gives propanol, and so on. So this is how we derive the names of the alkanols from their corresponding alkane. So generally, alkanols are derived from their parent alkanes by simply replacing the ending E in the alkanes with OL. So they are called alkane derivatives. But don't forget I said they are simply referred to as saturated alcohols. They are simply referred to as saturated alcohol because there is a replacement of at least one hydrogen atom attached to one of the carbon atoms with hydroxy group. That is a special characteristic of alkanol, the presence of hydroxy group in their molecules is what describes them as alkanols. Alkanols are saturated alcohols. Now, for better understanding, let's look at the meaning of alkanols. How do we define alkanols? How do we define alkanols? The definition of alkanols. What are alkanols? What are alkanols? What are alkanols? How do we define alkanols? Alkanols can be defined as saturated aliphatic. We are already familiar with these terms when we were taught hydrocarbons in our previous lessons. Saturated aliphatic compounds. They are saturated aliphatic compounds that contain hydroxy group. Hydroxy group is the functional group in them that makes them to be specially different from other compounds in their chemical properties. The functional group is hydroxy group. So they contain hydroxy group in their molecules. As their characteristic functional groups. Their characteristic functional groups. Functional group. We are familiar with these terms at the early parts of organic chemistry. We must have heard about saturated. We must have heard about the word saturated under hydrocarbon, aliphatic, as well as functional groups. These are terms used in organic chemistry. These are terms that you have come across from the beginning of organic chemistry to describe organic compounds. But just to remind us, I'll try to explain those terms again. Like I said, saturated. Alkanols are saturated. They are called saturated compound because the carbon atoms in their molecules are joined together by only single covalent bonds. Generally, in organic chemistry, when a molecule of organic compounds contains a chain of carbon atoms that are joined by only single covalent bonds. Take note, the carbon atoms that form the carbon chain, when they are joined by only single covalent bonds, then the compound or the molecule will be described as saturated, like alkanes. If you remember very well, the alkanes are saturated because the carbon atoms in their molecules are joined by only single covalent bond. So any compound in whose molecules the carbon atoms are joined by only single covalent bond will be described as saturated. So alkanons are saturated. By the time we begin to write some examples of the structures of alkanol molecules, you will see that the carbon atoms are joined by only single covalent bonds. Why are they described as aliphatic? Aliphatic because the carbon atoms, they join together to form continuous chain. A compound in which the carbon atoms are joined together by covalent bonds to form a continuous chain, be it straight chain, branch chain, or cyclic chain, or what I can call open chain and the closed chains. Such a compound is going to be described as aliphatic. So alkanols are saturated and aliphatic. That is, they contain carbon atoms that are joined to one another by only single covalent bonds, and the carbon atoms, they join together to form a chain, a carbon chain. And alkanols are also said to contain functional group called hydroxy group. Now, from this definition, I can draw out two important facts. What are the two facts I can draw out? The facts from the definition. The fact from the definition. That is the meaning of alkanols that I've given above. The first one is they are saturated. They are saturated and aliphatic in nature. They are saturated and aliphatic in nature. Two, they contain hydroxy group. They contain hydroxy group in their molecules. They contain hydroxy groups, that's OH, in their molecule. They contain hydroxy group, OH, in their molecule. So when you see a structure or the structure of a particular organic compound that contains hydroxy group attached to one of the carbon atoms, it means that compound must belong to alkanol series. So these are the two facts I can draw from the definition. Alkanols are saturated aliphatic compounds, and they contain hydroxy groups as their characteristic functional groups in their molecules. Let's look at examples of structures illustrating alkanols. Let's see structures illustrating alkanols. For example, let's see this. You have this carbon chain. As you can see, the carbon atoms are joined together by single covalent bonds, and that makes the molecule saturated. Now you now have one of the hydrogen atoms, because we are supposed to have hydrogen atoms at this end of the bond. If at least one hydrogen atom is now replaced, let's assume that we have hydrogen atom here initially. That makes it an alkane. This is butane. But if an hydrogen atom is now replaced, let's say this is removed, and we put OH in place, hydroxy group. I'm trying to show the bond between the oxygen and hydrogen. Try to show the bonds between the atoms as much as you can. This is a molecule of an alkanol that you can call butanol. This represents butanol. Why is it butanol? It is butanol because, one, it contains 4 carbon atoms, and the 4 carbon atoms are linked together by only single covalent bond. Then 2, it contains an hydroxy group attached to one of the carbon atoms in the carbon chain. So it's a butanol and is simply derived from butane. How? By replacing one of the hydrogen atoms with hydroxy group. So this is a typical structure of an alkanol. Let me give you another one. This one will contain a branch of carbon chains. So let's look at this one. This is another molecule of alkanol. This is another molecule, another structure of an alkanol. Now, if the hydrogen atom on that side is replaced with hydroxy group, it gives an alkanol. Just make sure that the structure is completely filled. Make sure that there is no mixing atom. As you can see, at the ends of the carbon atoms, you have hydrogen atoms and hydroxy group on one of them to indicate that it's an alkanol. By name, this is called 2-methyl. 2-methyl. Later in the next videos, I'll be teaching you the IUPAC naming of alkanols. Make sure you turn on your notification button and subscribe to this channel. So this is called 2-methyl-propan-1-ol. That's the name of this alkanol. This one consists of a single straight chain of carbon atoms, while this one consists of branch chains of carbon atoms. But both of them are saturated. Why? They are both saturated because the carbon chains in their molecules are joined by only single covalent bonds, and they both contain hydroxy group. So they are representing saturated alcohols, which are alkanols. So that is to show the definition of alkanol, to illustrate the definitions of alkanol. Let's move to the next aspect. I've explained the meaning and description of alkanols. Now let's look at the classifications. How do we classify alkanols? There are different ways of classifying alkanols. So let's look at the classification. How do we classify? The classification of alkanols. Classification of alkanols. How do we classify alkanols into groups? Based on certain conditions. There are two things we consider when we are classifying alkanols into different groups. The first one is based on the number of hydroxy groups. The number of hydroxy groups, based on the number of hydroxy groups per molecule of the alkanol. How many hydroxy groups are present in a molecule of an alkanol will determine the class it belongs to. So based on the number of hydroxy groups per molecule, we have monohydric alkanols. Those are the ones that contains monohydric alkanols. They contain only one. They contain only one, just one. Only one. They contain only one hydroxy group. These are alkanols that contain only one. Take note, just one. Only one hydroxy group per molecule. They contain only one hydroxy group in their molecules per molecule. Any alkanol that has only one hydroxy group in the molecule, as represented by the structure, it is going to be described as a monohydric alkanol. And we have examples. Let me try to show examples even from the structures we have written above. Those structures are representing monohydric alkanols in the likes of methanol, ethanol, butanol, propanol. They are all examples. But let me try to show the examples here again. For example, examples of monohydric like methanol. Methanol has one carbon atom. So if there is only one hydroxy group, it makes it a monohydric. This is methanol. This methanol. Methanol is a monohydric alkanol. Let's give another example. Let me give another example. This one is representing ethanol. It has two carbon atoms that are joined together by only a single covalent bond. So if an hydroxy group is attached to one of the two carbon atoms as follows, it is an example of monohydric alkanol. This is ethanol. Don't forget that ethanol is from ethane. Both of them have two carbon atoms, but in ethanol, one hydrogen atom has been replaced by a hydroxy group. So when there is a replacement of a hydrogen atom in an alkane molecule, it will give the corresponding alkanol. Methanol is derived from methane by replacing one hydrogen atom with hydroxy group. Ethanol is derived from ethane by replacing one hydrogen atom with hydroxy group. So these are just examples of monohydric alkanols. Alkanols that contain only one hydroxy group per molecule. Let's go to another example, another type. We have those ones that are called dihydric alkanols. These are alkanols that contain two hydroxy groups. They contain two hydroxy groups per molecules. They contain two hydroxy groups, only two hydroxy groups in their molecules. Two hydroxy groups per molecule. For example, let's take an example of this, like this. An example of dihydric is shown as follows. Then you have one hydroxy group on that carbon atom, another one on this carbon atom. Don't put them on the same carbon atom. So you have this. This alkanol is dihydric because it contains two hydroxy group. It contains two hydroxy group in that molecule. The first ones, they contain one hydroxy group in their molecule, and that is why they are called monohydric. But this one is a dihydric alkanol because it has two hydroxy groups. By name, it is called ethane 1,2 diol. Di means two, and simply known as ethane diol. In the next videos, we are going to look at, I'll be teaching you how to name the IUPAC naming of alkanols, and as well how to write their structure. So this is an example of a dihydric alkanol. Let's go to the third category, the third groups. The third group based on the number. Don't forget, we are looking at the classification based on the number of carbon atoms, the number of hydroxy group the number of hydroxy group present in a molecule of the alkanol. We have those that contain three hydroxy group, and they are called trihydric alkanols. Trihydric alkanols are alkanols that contain three hydroxy group in their molecules. 3 hydroxy groups. 3 hydroxy groups per molecule. They contain 3 hydroxy groups. Let's look at an example to show that. For instance, let's consider this. An alkanol that has 3 hydroxy group. So we are looking at this to illustrate a trihydric alkanol. There is OH on this carbon. There is another OH on the second carbon, and there is OH on the third carbon atom. Like I said earlier, don't put them on the same carbon atom. Don't put 2 on the same carbon on one carbon atom. Since there are other carbon atoms that don't have hydroxy group, you put them on separate carbon atoms. So this is an example. This represents an example of a trihydric by name. By name, this can be called propane 1, 2, 3. This is called propane. Propane 1, 2, 3. Propane 1, 2, 3. Triol. Triol means 3 hydroxy group. Propane 1, 2, 3. Triol. Simply known as propane triol. Propane triol. That's an example of a trihydric alkanol. We also have another category. These are the ones that contain more than 3 hydroxy group. They have more than 3 hydroxy group in them. Those ones are called polyhydric. Polyhydric alkanols. Alkanols that contain more than 3 hydroxy groups. They are called polyhydric. So they contain more. They contain more than 3 hydroxy group. Either 4 or 5 or 6 and so on, as the case may be. So they contain more than 3 hydroxy groups per molecule. An example is given as follows. An example is this. Let's consider this example to show a polyhydric alkanol that has more than 3. So that means you have an hydroxy group on each carbon atom in that chain. On each carbon atom in that chain as follows. Complete this structure by filling in hydrogen atoms at the end of the bond. So you have this. This is an example. This is an example of a polyhydric because it has more than 3, precisely 4. So how do we name this? This one contains 4 carbon atoms. So you're going to start with butane. That's to indicate the parent alkane from which this alkanol is formed. So butane, 1, the first carbon atom, 2, the second one, 3, the third one, and 4, the fourth one. So you can see that the hydroxy groups are placed on the carbon atom separately. So because they are 4, you name that as triol. Triol, simply known as butane tetraol. Butane tetraol. So that is an example of polyhydric alkanols. So in the next video, we are going to continue from where we are stopping here. Don't forget to subscribe to this channel, share and like the videos as you watch them, share with other groups you belong to and other fellow students that can also benefit from this. Like I told you, we are going to be taking series of teachings. So we have just started the first part of these teachings, looking at the meaning and the classification of alkanol. In the next videos, we are going to continue from here. Please make sure you subscribe to this channel and try and turn your notification bell on so that you can have access to the complete series of teachings on this video. See you in the next video. Stay tuned.